computation of circle diagram. Now, for the sake of this, let me repeat where we began, where we were saying circle diagram shows the performance characteristics. It shows the performance characteristics of induction motor using a circle locus. Using a circle locus. And then we say that the data obtained for the diagram are from 1, the no load test. No load test, we said this is a test that is carried out when there's what? There's no mechanical. We are saying mechanical no load. So why do we carry it? Our main reason for this test is to obtain 1, the no load power factor, which is known as cos phi naught, and 2, to obtain the no load current I naught. And then number 2, we are saying we can also obtain this from what we call short circuit tests or blocked rotor tests. This is done when there is mechanical load. The reason why we do this, one, we obtain the short circuits PF cos phi s. I'm repeating this because we are with you there. Then we have short circuit current with what? With what? Normal voltage. A current we are calling I what? What was ISN? ISN? VP over VS times I, the short circuit current. Right? And then number 3, we get what we call short circuit power what? Power with a normal. Normal voltage. What we are calling PSN. PSN is the primary voltage over secondary voltage, but the power is squared times the short circuit times the short circuit what? Power. Or root 3 V ISN what? Phi s. So in either way you can get the PSN, the power that we'll use is called the short circuit power with a normal voltage. So you either use this formula or this one. And then of the torque line, location of the torque line. Now, location of the torque line, I want to say, I'll use some letters, A to E, E to F is equal to rotor copper loss over stator A, if you look at this line seems to be one line where we are coming from A going to where? To F. Huh? So A to F looks to be the total copper what? Copper loss. So we need, there's a E somewhere so that we have the rotor copper loss and the stator what? Copper loss. It will be one line, but we are trying to locate point E on the same line, right? So that's where we get E will be where our torque line is.
How do you locate point E?
By using the ratio of rotor copper loss over stator copper loss. It's a ratio.
Oh.
So it means this is a total copper loss. So the ratio of this to this. Huh? Yeah, there might be a ratio. Or might be a way leading to that ratio. Okay? This is for squirrel. The case I'm saying here is for squirrel cage. Now for the motor we call slip what? Slip ring motor. We can say A to E, E to F is equal to rotor copper loss over stator copper loss. Now let I1 and R1 be the stator current, I current, huh? And resistance respectively. So that I2 and R what? R2 be the rotor current and what? Resistance. Now how do you get a copper loss? This is a sideway. Any copper loss is given by I what? I squared what? R. And therefore once we have declared I1 is the stator current, R1 is the stator resistance, therefore we can get the stator copper loss and the rotor copper loss and stator copper loss. Sure. Is that true? I'm saying a copper loss is given by I squared what? R. And here I've declared I1 is the stator current, R1 is the stator resistance. Can we get the stator copper loss? Yeah? And here? And therefore we can say that A to E over what? E to EF is equal to rotor copper. I'm repeating for the sake. Copper loss over stator copper loss, which is equal to what? What is rotor copper loss in this case? I what? I2 squared R what? Sindio? And then I1 squared R what? 1. That will be the copper loss according to this. But then we recall, what do you recall? That K is equal to what? K is equal to what? N2, N1, V2, V1, I what? I1 over I2. Because the current is inverse. Huh? And that means if you look at this element and this element, don't you see some similarity? Yeah? Over K. So what will be the K here? This is a K is I1 over I2. Here we have I2 squared over I1. And therefore that we can say A to E over E to EF is equal to 1 over K squared. Nikweli? Sindio? This invert, right? R what? R2 over R1. Is that correct? When we are looking at what we call the transfer of impedances, we said when you transfer values from secondary to primary, we do what? We divide by K squared. the law of impedances, right? That when you transform values from secondary, secondary to primary, then do what? Divide the secondary values by what? By k squared. This is a law of impedance. I think I mentioned it there before. That means then there's an element of R2 divided by k squared. True? Huh? There's an element of, how do I rewrite this? This can be written as R2 over k squared times 1 over R1. True. And therefore, because of the impedance, the transferred value of R2, that is R2 prime is equal to R2 original over k squared. That implies that A to E, A to E to EF is equal to, so what do you have when you use that? R2 prime over R1. What was silence? I'm worried of that silence. Huh? What? Okay. Now, the rest are in the procedure when I have example. So I want to start with a very basic example, very basic, without complications. That first example says, draw the circle diagram. Example, draw the circle diagram. From the no-load and short circuit tests, draw the circle diagram from the no-load and short circuit tests of a three-phase, 14.92 kilowatts, 400 volts, 6-pole induction motor from the following test results. From the following, yes, machine. These are the results. No load of 400 volts, 11 amps, a PF of 0.2. Blocked rotor, blocked. 100 volts, 25 amps, a PF of 0.4. Last statement, the rotor copper loss the rotor copper loss at standstill. The rotor copper loss at standstill is half the total copper loss. Is half the total copper loss. From the diagram, find. From the diagram, find. From the diagram, find. Roman 1, the input stator current. Input stator current and its power factor. Input stator current and its power factor. Roman 2, the slip. 3, the efficiency. And the maximum efficiency, Roman 4. Maximum torque, maximum power developed. Combine them because it's one procedure. Maximum torque, maximum power developed. I hope this is taken to work from the central surface. Meanwhile, you do that. We want to obtain the data for drawing. The data that are given here cannot draw. So you have to obtain the data for what?
Drawing.
For drawing. One, these data are given in amperes, but we want to draw in centimeters, right? So the first thing is to get data for no load. The no load, we said the first thing we get is what? The no load PF, which is cos what? Cos phi naught. So this detail is here because there's a power factor of 0.2. So we need to only change that into degrees by getting this is equal to cos inverse of 0.2. We'll have that power factor is in degree. Point? So if you say that 0.5. 2, we need the no load current. Of course, we have just been given a current here of 11 what? 11 amps, right? Remember when I was outlining, I said when at no load, we need the no load power factor, no load current for us to draw. Once we get those two, we are safe. And therefore, we go to the block, rotor, where we have 100 volts. How much is the current? 25, a PF of 0.4. Here we said we start with the cos phi s, which is given to be 0.4, right? So you need to change it also into degree by saying phi s is equal to cos inverse of 0.4 in degree. 60. 2. What were you supposed to obtain part 2? The ISN, which we said is equal to what? The primary voltage over the short circuit, the secondary, multiply by the short circuit what? Current. Up until what wanasahau, they use this current without getting the ISN. You'll be wrong in that data, right? So this is 400. That's the primary. The voltage of secondary is 100. Current of the secondary is 25 amps. This one. So we get what? 100 amperes. One more. Something here. The power what? The short circuit power with the normal, the PSN. If you look at the two formulas, I gave two formulas for PSN. One says what? Oh. One says VP, VP over VS squared times PS, or root 3 VL ISN cos phi S. So if you look, we cannot use this because we are not given power of the short circuit. So the formula number 2 applies so fast, right? So we are saying this is root 3, 400, ISN is 100, cos of that is 0 point, right? Yeah? So that should give us the PSN. Once we get the PSN, I want to write the answer first. 20?
7
Mm-hmm.
0.8 watts.
We need to start to draw, but then we need to draw when we have a scale. So we want to open the scale. So this is called the current scale. There will be two scales. The current scale, how do we get the best current scale? We look at the ISN. The ISN should tend to 20 centimeters. Your scale should reduce ISN towards what? We are saying towards. That means slightly before or slightly above. So if you look at our value here, 100, what will reduce it to around 20 centimeters? 5. And that get me and say, let 1 centimeter be equal to 5 what? 5 amps. I've declared a scale. So once you declare the scale, the no load, what was in the no load? No load is 11 amps. You divide by 5. I think you get 2.2 centimeters at an angle of 78.5 degrees, right? ISN is equal to 100 amps divided by 5, you get 20 centimeters at an angle of 0.4. I'm bound to change. So once we have this, we can get, I need somebody to sacrifice one paper. And have your point O. The origin O. Once you have the margin, please get this. I know the teachers of KU, they taught well in mathematics and said this thing can only work measure degree when ikikaa hivi. But our reference voltage is here. So this is our 0, right? So if this is our 0, where is the 0 on this? 0 degree? Here, right? So this thing can only be measured like this. So that's our 0. So that the first measurement is, answer na degree, we start with the degree, 78.5. At what? 78.5 and 2.2 centimeters from origin. I will enlarge mine. What can you see? And once you do that, have the O prime. I've said a degree of 78.5 and the length is 2.2 centimeters. Then have a O prime. Hiya. What do you have? The next measurement is 66.4. So take the protractor 66.4, going that way, you get your degree, and the measurement, the length is 20. Take the protractor 66.4, a length of 20 centimeters. And mark A prime. No, A, just A, not A prime, A. Mind for your lines. Then I need to bring some data. I hope you copy these ones. I want to write small notes on procedure. Capture them. So 1, draw a line from prime parallel to the base. I'm still waiting for this line because this one you cannot watch. This one you have to do. Extend more of that line. Line parallel to the base from O prime line parallel to the base from O prime Where is your O prime? At what point? Yeah, that's why we need the line. There's a O prime, O. Remember to write them. O prime, O. These are A. Ensure the letterings are there. I'm not seeing an A. Do you have an A? Do you have an A? Weka. O prime. Procedure number 2. Join O prime A. O prime A O prime A bisect O prime A. You know how to bisect? Simply like compass. Let the compass be more than half. If you are at O prime, at A cross, that will be the bisector. That will be the bisector. Bisect O prime A. And then the bisector is passing through the line parallel C, the upper parallel, upon C. This is the last point. Huh? Well, this half. Try. Yeah, itakata. From O prime. Next, with C as the center and CO prime radius. With C as the center, that's where your compass is, and CO prime radius, draw the locus. Huh? Draw the locus. Ensure passing through what? Must be passing through? Passing through A. I'm saying, with C as the center, you have the compass there. CO prime radius, that's where your pencil is. Draw the locus. Draw the locus through A. must pass through A. Is it passing through A? If it's not passing through A, there's an element of inaccuracy somewhere. You have the locus? Somebody is struggling because it's not passing through A. You cannot fabricate now. Leave it alone. It's too late. Drop a line from A perpendicularly. Perpendicularly. Drop a line from A perpendicularly. Creating point F and G. Creating point F and G. Drop a line from A downwards, having point F and G at the base. Now the critical point again is here. Locate the torque line. What were we told about the torque line? The rotor copper losses. Back to the question. Equal. Equal to R total. So the total copper loss is AF. Right?
Yes.
So we need a line between A and what?
F.
That means what? Bisect AF. At point E, right? You bisect it at point E. You bisect at point E and take point E back to O prime. So this is the torque line. This is called output line. For now you can write, don't write in exams, we know. Huh? Any other drawing, don't draw. The current drawing, you can do that for your reference. Theta, copper loss. Those lines are very important. So once you get E, take E back to O prime. Huh? That's what we call the torque what? The torque line. Huh? Yes. Aya. I'll say, locate the torque line. In the statement, this statement is there. Read the last statement before you give the data. In your equation says what? Where it says the rotor copper loss? Yes. That's where we have got an E. So AF is the total copper loss. Therefore, what is half of it? Is the bisector of the same, right? I want everybody to reach here because I want to change gear. And this is where all people lose the point on circle diagram. The next gear where I want to change. Everybody must reach here so that I change my gear. You not this. You only bisected E. You see, I've taken E back to O prime. You don't have that line. Are we there? We are there? So I can change the gear. So we need to get the power scale. We need to get the power scale for this question. Power what? Power scale. How do you get the power scale? For us to get the power scale, appropriate power scale, this is what do you declare? That A to G, that is measurement, is equal to PSN. EO2. That's the point you need to remember for us to get the power scale. That A to G, your A to G is equal to our PSN. Remember PSN we calculated. Yeah? So somebody should measure its AG. Somebody? I know they will be starting to vary as many as we are. AG? Huh? 8.4. Let me use 8.4. Centimeters is equal to, what was the PSN in value? 712.8 watts. And there we are saying if 8.4 centimeters is equal to 12.4 watts, therefore, what will be 1 watt? 1 centimeter, right? So we are saying 1 centimeter times 712.8 over 8.4 should give us 1 centimeter is equal to how many? How many watts? Wale wa 30. I depend on those who gave me this value. Please use your value. Trust your value and use it. Those who gave me 8.4? 32.99? 14. So we have declared another scale that says 1 centimeter is equal to 32,999.1 watt? 4 watts. That is a scale for power. But while you are drawing, there's part of this circle that is not covered by this drawing. So there's an extension that's remaining outside here. While you are drawing, according to the rating, not all the parts are included in the circle. And therefore there's a part, I want to call it S. You are going to locate, don't draw like I draw, wait until you draw it. I'm declaring why we want to get that. That when we are drawing our circle, there's a part according to the rating of the motor that could be outside the what? The circle, right? Now how do we get this point S the location of point S how do you get point S? This is how we get S. A to S in measurement is equal to the rating of the motor over power scale. You're getting me? There is a point S that is not within this. And how do we get the value of S that is not within the circle? It's the rating of the motor. You'll be given the rating of the motor. And remember, we have declared the power what? Power scale. So in this case, we are saying, what is our AS? Rating of the motor was declared in the question?
14.92 kilowatts.
14.92 kilowatts. That means 1,000 divided by 32. Please use 144. 14. So what will be AS? Those who get this value, what will be the value from A to S? .5, huh? So measure from A 4.5. From A 4.5 and get the value of what? Get the location of S. Measure A from A, the value that we've gotten. Come on, 4.5 from A 4.5, and then mark that point what? A? S. You better dot it because it's not part of the drawing. It's outside. Yep, S. Some people are doing S. Surface yangu ya kufanya hapa kameisha. Another point, that is locate. This is that point, then locate the last another point from S. Draw a line parallel to the output line. From S, draw a line. What to substantiate that? From S, draw a line parallel to which one? Output line. So I'm not sure your level of drawing. So please do this. This is for Gumbaru. Do this. At point A, you at A, measure S with a compass, right? Go somewhere, anywhere here, mark that value, right? You will get the same displacement, which will parallel, and then drop this. Let me try to fix this. Don't do that. You will not be accurate. Did you find where I was getting? I don't want you to use the set square. I've said this is the high level working so fast. You know the value here. Sindio? So with the compass here, stand anywhere on the line of the output and mark. Huh? Right? You can even mark 3 of them. Huh? Then join those points. You will have a line parallel to the what? To the output. Huh? Wait, we'll be cutting the circle into 2, but I'm interested in the last one. Mark it P. We'll be cutting the circle into 2 twice, but mark the last one, the down one, P. How is it within the circle? Yeah? We are landing. Join P to O. Join P to O. We are landing. Huh? From here we can start looking at our questions. Roman 1 ilikuwa unauliza nini? You extrapolated a P. P is on the circle. The point touching the circle. Huh? Yeah. So what is the question? First question, get back to the questions. We want to answer those questions now. Drawing is over. The first, Roman 1, input, stator, current. That is input, stator, current. I what? This is equal to OP times the current scale. Measure your OP, that's what you mean, huh? OP times the current what? Scale. What was our current scale? 1 is to? 1 is to 5. So measure OP times the current scale. Huh? Somebody's? 8.? 6.8 times 5. Use your value. The power factor is equal to angle O PV. I don't know how we do that. Is that true? No, it is P O V. This angle, the cos of that, cos of theta 1, the cos of, you remember how we were measuring the so that angle, the cos of it is the power factor. Question number 2. Question number 2. Power factor. Somebody is asking. I've said the way you are measuring the angle, this angle, the cos of it is the power factor. Lag. Remember to write lag. Another one is asking what? Part 2? The what? Slip. The slip. This is what you do. Drop a line Drop a line from P. Drop a line from P. Where is P? Perpendicularly. This line is L, K, N, M. Nimeanza chini. I've started from down one. L, K, N, M. How did we measure the angle? Same procedure, my friend. So you got 78.5. So the angle moved from here, going that way. Huh? What did I say? I said POV. And look at how you are putting the protractor. So that cos of that, the cos of that is the power factor. Have you dropped a line from P? Huh? With L down, K, N, M. Start from down. There's a line hanging there, so if you start from up, drop a line from P first. Straight line. So what is the slope? Slope is equal to Mn over Pn. If you want, you can do by 100. Slope is the ratio of Mn over Pn. Slope should be tending to 0.0. Yeah, slope should be tending to 0.0. Then 3 is what? Efficiency. Same procedure. Efficiency is PM. That is P to output line over P to total line times 100. Efficiency is equal to P to output line M to P to total line efficiency. You have efficiency?
76.27.
Ile swali imebaki. What was the last question? The maximum torque. I want everybody to be at that part. I demonstrate the maximum torque. You have the efficiency? Maximum torque. What do you do to get maximum torque? C as the center and torque line as reference. Mark an arc. This is what you do. C as the center. While you are standing at C, this is maximum torque. Mark an arc on torque line and another arc. Are we there? Yeah? Then extend those arc. While you are standing at this arc, you draw that. At that arc, you draw this. Let me repeat. While you are standing at C, make an arc, right? Then the other arc, the other side, right? Then on the same arcs you mark, on this arc, extend your compass and cut and make an arc and cross that arc. Then drop that point back to C. To C. As torque as the reference. While you are at C, mark an arc on the torque line both sides. Extend those arcs outside the circle. Drop that point back to C. Are you there? Huh? Where that line is touching the circle, what do you make it? Mark it T. Where that line is touching the circle, mark it T. You dot and mark. Huh? Where that line you drawn is touching the circle, mark it T. Hata munaanza kushuka kwa gari. Where is it? This here. While you are T, drop a line from T back to torque line perpendicularly. At T, drop a line back to torque line. Mark it Q. From T, drop a line back to torque line. You are marking that here outside the circle. Check. I've said where the line is touching the circle, mark T. I'm seeing your T is outside the circle. Are you sure it's on the circle? Make it at the circle. Where the line is touching the circle, mark T. Drop T back to torque line perpendicularly. I mark it Q. Guys, that torque line is our reference. We'll repeat the torque line. T T to torque line. Q. So TQ is our maximum torque times power scale in a unit called synchronous watts. T to Q in measurement times the power scale is our maximum what? Torque in? Huh? Top a line perpendicular back to torque line. From this thing is not in the circle again. Where is your circle? Yeah, I've said where it's touching the circle, that's where you drop. Then from there drop that line, that's where T is. Rub the other T's, they'll confuse you. So TQ times the power scale is the maximum torque in synchronous what? Watts. So somebody will ask you, find that maximum torque in Newton meter. The other day we were saying 1 synchronous watt is equal to what? 60 over 2 pi times ns. The next question says maximum power developed. Same procedure. It's mama at C, but our reference is output line. Hey, same procedure. At C, our reference is output what? Line. Right? Extend that line out. Drop that back to what? To C. That line is already there. I just want you to prove a point. Okay, so when you are there, you just find that line is already there. But go through the procedure. Standard C, output line, extend out, drop that line back to what? To C. Unaiona wapi? Where's the procedure? Where's the procedure? Make the procedure, prove the procedure. There's 1 mark for procedure, not of Samson. At C, cut the output line, both sides, extend out, drop that line back. And where that line is, that line already there. Did you get it at that point? Huh? X. Then drop it back to output. Output. Y. X. If that line is touching the circle, X, drop it back to output again. Your reference, just the same way. Your reference is now the output line. So maximum power is equal to xy times the power scale. This is in watts, huh? Wapi sasa? Where's the line? I said it's mama at C. Where's the campus? You know, you cannot do that like for you cannot do that EG EG line. Where I see, make an arc on the output line, both sides. then extend them out from those arcs. Please, we need a procedure. Don't assume. So you found a line. So where that line is touching the circle is X. That's what I'm saying. Prove that it's there. So drop X back to output perpendicularly. You dot. If you want to be careful, you dot X. Where they are touching, you dot so that you show it is here. Drop back to output to get Y. Yeah, I'll mark it Y. So Yx times the power scale is the maximum power output. Now, just for references, there's still, you can be told, determine the maximum input power. Maximum input C perpendicularly. From C perpendicular to the what? Yeah? That line from C to the circle. That's what you call the maximum input power. Yeah? You multiply by scale. It's just like the radius. Isn't it? Yeah? Or that circle. I want to give this homework. Maybe if you want a hint, I will tell you. But it's touching on the second part where I was talking about
from C to Z ni maximum
input power. So check this at home. You can try this at home. Maybe I will give a hint on why this is here, the last part. So write this. Draw the circle diagram. Draw the circle diagram. Draw the circle diagram. For 5.6 kilowatts, for 5.6 kilowatts, 400 volts, 3 phase, 4 pole. If I'm fast, piga kelele. 50 hertz, slip ring induction motor. Slip ring induction motor from the following parameters. Slip ring induction motor from the following parameters. No load readings. Give it a line. No load readings. 400 volts. 6 amps, 400 volts, 6 amps, power factor of 0.087, power factor of 0.087. Another line, short circuit readings, 100 volts, 12 amps, 720 watts. Another line, the ratio of primary to secondary turns, the ratio of primary to secondary turns is 2.62. 2.62, and the stator resistance per phase is 0.67 ohms. 0.67 ohms, and the rotor resistance is 0.185 ohms. Calculate Roman 1. The full load current and its power factor. The full load current and its power factor. Roman 2, full load slip. Roman 3, maximum torque. And lastly, maximum power, 20 max. The goodness of this thing inakujanga package, full package, 20. Huh? But don't be overconfident to try this if you know you are, because it can consume you 2 hours, 2 hours over 3 of the 3 hours in exams. But if you are confident, you only need 15 minutes. Yes, maximum 20. Few hints. While you'll be looking for torque line, remember here the ratio has not been given. It has taken us back to what you are used to say, A to E, E to what? F is equal to R2 over R1. Where's the K? Yeah? Yeah, because K will lead us that R2 prime, this is R2 prime, is equal to R2 over K what? K? K squared. So where is K? K is, that true? What was R1? 0.67. R2? 0.67. So that means A to E over E to F is equal to, no, if A to E is this answer, 1 over that, then you can know where E is. A can tend to be down or up, depending on the ratio you are going to get, right? The torque line, yes? So that means what? So the primary to secondary means the inverse.
Yes.
So what are you implying? 1 over 2.6. Now deal with this first.
It will be 0.185 times 2.62 squared all over 0.67, which is 1.9.
That's what I want. This question will be carried from Taraja. So it's 1 point. So please follow what he's saying. 1.9. So when we say, please listen to this. When we say that A to E is equal to E to F is equal to 1 point what? 9. Then what will be the total? For us to get AE. AE is like 1.9 over 2.9. Why? It is 1 to 1.9. See that's the ratio?
Yeah.
Huh?
Yes.
Yeah. See, this thing says the ratio is huh? Sindio? So that you get exactly where you are going to get E, A to what? A to E. And then you locate E. You'll maybe find it's up or down. That's the technicality why those resistance is given. The rest remain the same. The same.